Compared to fixed treatment, clear aligner therapy, so-called CAT, is currently the preferred technique to treat malocclusions. CAT is based on a thermoplastic polymer that exerts the force on the teeth surface to move them in a bone generation and absorption phenomena. The thermoplastic polymer used not only should withstand the oral environment, but must be able to deliver the right amount of force as continuously as possible to make the treatment comfortable, painless, and effective. Therefore, the aligner performance, to a high extent, is decided by the polymer properties, such as chemical property, physical property, optical property, thermal property, etc. Today, Mr. Kevin Huang, founder and CEO of Maxflex, will take us through the material chapter and some key polymer properties.
Hi everyone, I'm the founder of Maxflex medical technology company. Maxflex focuses on clear nanotherapy related business more than 10 years. We provide one-stop solution including raw material, processing facilities, production optimizations, and accessories. Based on years of experience in clear nanotherapy area, our team would like to share useful information with the global orthodontics, dentists, and customers who want to know more details of clear nanomaterials and performance difference, and how to optimize its processing technology. We also welcome more participants' feedback to give us opportunities to share in-depth knowledge and improvement in the clear nanotherapy technology. Let's have a look at the evolution of clear nanomaterials. Clear nanotherapy technology was launched by Anitech in 1998. According to statistics, clear nanotherapy grows very fast within more than 20% annual growth rate during past 20 years. In the past 2 decades of polymer evolution of clear nanomaterial, various polymers was chosen to be the nanomaterials. Some phased out and some still popular until today. However, there are still many mysteries regarding to clear nanotherapy performance. For example, what are the differences among various nanoproducers? The balance between comfort and the teeth movement efficiency. How to choose the right aligners material? Why materials aligner is preferred choice? Does a aligner produce comply with denied by software? Other issues such as cracks, stains, refinements, allergy, stress retention, aligner deformation. I hope through this session, we can provide a better idea for above questions. Currently, most popular aligner materials chosen by branded companies are copolyester, thermoplastic polyurethane, and its combination. Thermoplastic polyurethane, abbreviation called TPU, is a broad family of plastics composed of soft and hard segments in the main polymer chains that are bounded by relation with diisocyanate with a short-chained diol and another diisocyanate and a long-chained diol. If we only look at the hardness of a stiffness perspective, TPU can be very rigid, hardness higher than COD 80. On the other hand, TPU also can be very soft, with hardness level around COA 70. The rigid TPU now is widely used as a typical material for retainers, and the soft TPU now is used as one of the layers in the multi-layer aligners. Copolyester is basically glycol-modified PET, PETG, and PCTG are the most widely used for aligner and retainers. Triton is a typical copolyester with high TG, making it an excellent polymer choice for aligner. Have a look. For available medical material for clear aligner, including the hard TPU, soft TPU, PETG, PCTG, EVA. EVA normally is for sports guard. And the TPAE, some limited branded company use TPAE, and the polypropylene and polyethylene. They are also used for sports guard or night guard. And the TPU and the copolyester is most widely accepted material for clear aligner therapy. And among the design of the dental foil, actually there's many kinds of monomers and also the polymers can be chosen, and also the combination to choose as a multi-layer Right now they have the single layer, double layer, multi-layer, and multi-layer also include tri-layer, and also the 5-layer invented by 3M. So there's so many choice for polymers used for clear aligner therapy area. Little bit more details, polymer properties related to aligner needs. For example, let me go to step by step. First one, you need to have aligner have a very good fabrication. So, which means fabrication means the polymer needs to melt from solid state to liquid state. So it will relate to polymer melt viscosity, and also it related to its mechanical property and TG, glass temperatures, and the melting point, and also water absorption. And also, second step, you know how to demolding, because you use whether you use the 3D printing molding. So if you want to make the tailor-made aligner, then you need to do the demolding process, demolding on 3D printing dental model or dental plaster model. Then you require have very good demolding properties. Then it related to the both surface energy of both material, like dental foil and also the 3D printing model. And also it related to the mechanical properties, both on 3D printing model and also the aligner material. Because if some material they're very sticky on the, if you have higher pressure, then you have the also like the Invisalign, the material on the surface is very soft. They have a problem with the sticky on the dental model. So you need to have some kind of release agent, or you need to have a protective film. This protective film may be made of the polyurethane material, which have lower surface energy for help you to do the demolding process easier. So the third step, we're talking about the safety and the odorless. This is also very important because the patient where the aligner need to smell nothing. So we need to require a lot of biocompatibility test, and also the chemical properties, and also require there's no polymer degradation during the wearing period. It means that for the patient, normally right now it's about 7 to 14 days. Then there should be not any degradation. But as I know, some patient will wear aligner to eat the food and also drink the hot tea. Then this will be create some kind of bacterial attack the aligner. So the material, aligner material need to have very good stability for in the hot and the humid condition. Fourth step is need to be clear. Of course, when we call Invisalign or clear aligner, they need to have very good optical properties and the transparency, which means right now, as I know right now, more and more adult person they wear the clear aligner because it's invisible. It's a very good high transparency, not like the fixed braces. So this is a good point that you need to choose a good high transparent aligner material to make an aligner. And also the most important things would be say forcing retention. In the old days, and even now, still have many countries they are used the single layer, and like the polyurethane or the copolyester, they have a very poor force retention. Normally about 2 or 3 days they will drop more than 50%. And the reason is that because most of this material they have a lower glass temperature, and in the oral temperature is about 37 degrees C, and so which means the polymer will have decay their force based on this high humid and also high temperature. Force retention need to have a high TG material. This is the reason some of a good material they need to use much higher TG, like the Triton material. And based on this material, is one of the key points to have a force retention. So it maintain elasticity and also quick reaction much lower, and also depends on how you organize more molecular structures. You can make have a more branch segment, means the force can be not just the force can dissipate to other area then instead of one direction, so to make the electricity can come back faster. And then let's come to the dimension stability, because a lot of material, they have two kinds of materials very important. When you do the 3D printing model, a lot of material, they have a lower molecular weight. Then the dimension stability will be an issue, because when you do the pressed forming, then 3D printing dental model, they will change with shrinkage. So need to have a good calculation about how to compensate the shrinkage. So also when you do the retainer, you hope the retainer can press 3 or 4 times to make 3 or 4 pairs of retainer. Then you need to have more heat resistance and pressure resistance, and to avoid this dimension stability have some problem. I would say another issue is that when you want to do the cost saving, then you need to make a hollow structure of the 3D printing dental model. Then it will make it save the more material, but you also have a damage on this dimensional stability. And also for aligner, there's another issue that if some material they absorb more water, then during the welding process, then you will create another problem, is that they absorb the water. That means this dimension will become bigger, and so during welding and takeoff process, then we'll have another issue, is that its dimension stability will be changed. So this is also something we need to look at that. And also the seventh factor is called elastic behavior. This is very important. The reason that right now major trend that they use multi-layer is because during the multi-layer, where is outside or inside, then this kind of 3-layer, they use elastic material in the middle or in the outside is to provide the elastic behavior. This creates better crack resistance and also recovery. Actually, not just 3D direct printing material have this kind of called shape memory property. Actually, most of the elastomer, they have this kind of shape memory properties. So I would say that we call 3D direct printing the shape memory behavior is quite tricky. It's not really it's a very, I would say it's a normal phenomena for most of the elastomers. So elastic material is very good to have a better crack resistance and also better force retention, because they absorb the energy to different and then spread out to different direction. Then I would say crack fracture resistance also is a very important factors, because also related to the people. A lot of the people, they didn't have a very good well in the takeoff of the process. They will create more force or more crack during the welding process. I would say that if our material can have a much longer, I would say, yield strength, I will explain later, yield strength point, and also can provide a longer crack ratio, then they can have a more durable material during the welding process. Heat resistance also is very important. I would say that most of the poor material, I think not many patients look at that, because they want to wear a liner to drink the hot tea or hot coffee, which the temperature is about 55 to 60 degrees C. And with some of the like PTG, the TG is only about 70 degrees C, which means if you drink hot tea, actually the force will decay very fast. Then if you drink hot tea, there's almost a big influence about the orthodontic force. Then it will make the movable teeth lose its efficiency very quickly. Stain resistance is also one of the most important performance, because it related to the surface structure. So some aligner, they don't use protective film, and if you don't use protective film, if the patient wear the aligner without protection film, there is a very clear laminate structures during the 3D printing dental model. So which means aligner also shows this kind of figures on the surface. So you can see the liner is not so transparent, then you can have a lot of chance to have a material stain on that, have a lot of like a tea or coffee stain on that, then its stain resistance is very poor. So I would say if you use a softer material on the surface, then you have a problem that the soft material is because when it's soft, it means it's tradable, which means soft material always can absorb a lot of the colorful material, such as the wooden wine, the coffee, the tea. So if you want to have a better stain resistance, I always suggest that you should need to be more smooth and more crystallized material, such as copolyester or hard TPU, and have a also the lower surface energy on the surface, so which means the stain will not stain on the liner. So you can do the stain resistance test by yourself. Put the liner in the coffee and see how fast it becomes stain. Another one is to say wear durability. Wear durability because some of the patients they have the grind their teeth quite often. So good material need to have not just the material have very good abrasion resistance. Also, if we have some elastomer material in the middle, then you can have some better elastic material when people have this kind of abrasion behavior. Then they can release this kind of pressure, make the patient during the sleep condition, they have a better feel more comfortable. Instead of the hard material, then they have make a lot of noise and also have a bit abrasion on the teeth. And wear comfort is more key. I think I met a lot of customers, and it's very interesting. They say, "Oh, okay, I want to move the teeth. I need to higher force." Actually, higher force is not really the key to drive the teeth movement. The key to drive the teeth movement is that the continuous and softer and the teeth. Normally, according to the clinical trial, normally they need to minimize 17 hours wear experience. So when the performers want to show us how to move the teeth, the best way is that you need to have a very moderate forces. For example, I give all some references, such as if you use like more mechanical properties of those single layer, they will say they are modulus. I was saying the stretch modulus, it would be TPU is something like 45 megaparts, and polyester is about 41 megaparts. But if you make a multi-layer, it would be something like 25. But when you wear it, you can see the difference is comfortable is quite big. But when you wear it, then the key is that if you single layer, because as I said earlier, they will decay so fast. Normally, for the 2 or 3 days, they will decay more than 60 to 70%. But if you use a good multi-layer and with a good electricity, they still can keep about 70% performance. So it's nothing related to higher force to drive the teeth more fast. It's related to continuous and comfortable force to move the teeth. So based on this, we can go more details later. Okay, let's go to a more detailed step-by-step talking about the liner fabrication. So when you make a liner, you need to understand the polymer melt viscosity. I take a daily life example, like the shingles and metals. If you see the metals, when you melt the metals, actually the viscosity, the change is more slightly lower than the shingles. Shingles, you melt it, it's just like a liquid, and they become this more crystallized phase, so they become shingles become solid very fast. But metals, they will become crystallized more slow. So you can feel that the shingles is more stuff and the metals is more soft. Even they make some of the sugar, you can feel very viscosity. Viscosity is very high. But I take this as an example for people to understand different polymers. Because their melting viscosity behavior is quite different. So you really related to how you make the liner, because when you heat in the material, then you do the fabrication. The problem is that because of pressure, because of the temperature, and it's a kind of cooling down process. So if the viscosity changes too fast, then will be the thickness distribution will become various and become bigger. But if the viscosity is not so change a lot, then the thickness distribution around the aligner will be more stable. So this is very important. No, so I will say we define the polymer viscosity as the polymer ability to flow where heating and subjected to force. So you can see this diagram. And during the thermoplastic process, polymer transition from solid to semi-solid or liquid, or we call viscosity state, under the heat and the pressure. So like the polyurethane, you can see some material, if the softer material and the harder material, the viscosity change with the temperature is a big difference. So we call some material, if their viscosity didn't change a lot, or we say male viscosity is higher, so which is more easy to process, or we can say its processing window is wider. So this is very important to understand that. To make it a good aligner, they related to two important factors, even on the same processing machine, with the same pressure, with the same temperature. The different material, aligner material, if they didn't process, actually the thickness of different material also shows different thickness distribution because its male viscosity behavior is different. So I will show this diagram. So if we use the multi-layer, there is kind of compromise of the two kind of material. So we'll make the thickness distribution more even. Later on, our another colleagues will show all the data on another chapters. Another important is that currently many precision facilities, they don't deny use the right idea. It means the heat distribution of the whole heating area is not really even. Like if you use the circle heating system like the BioStar or Ministar, they in the during the heating system in the center area is very easy to have overheating, more than 25 degrees higher than the edge area, which means that you put a liner, a dental model to make the liner, then you will think about that in the interior part is much thinner than the model part. So this is very important. So if you make a good processing condition with a good pressure and a good temperature distribution is very important. So you can easily to measure that using the thermal diagrams, or you can use the industrial CT scanner, or use some optical scanner to measure the thickness distribution of the liner to make sure you make the right thickness distribution on the liner or not. And also, I would say the thickness usage ratio is also important. Means if you have a very even and a very good pressure distribution and the heat distribution on the aligner, you can use the thermal diagram to make sure all the aligner is during the heating process is under very uniform heating and the pressure condition, and then you can have a very good draw ratio for each part of the material. So when you draw it, then you can see all the material have been drawn very even. Of course, because the interior teeth is longer than molar teeth. So I will say that another issue that normally during the 3D printing dental model, they will make the molar teeth higher to compensate the draw ratio difference. So this is also related to the 3D printing design program. The software program will help you to compensate some loss because of the draw ratio difference. Another one we say the impact on the product quality, because thickness uniformity is very important. During the treatment plan, everyone just follow the treatment plan, say, okay, you want to move this, say, 0.2, 0.25 millimeter. But however, if your thickness is not even, it means it's not really move the teeth evenly. So it means that it's not really can predictable to move teeth under the treatment plan software. So we need to find some good way to measure and to see where this thickness of the all liner for each part it will be more even. And also another issue is that if the thickness distribution is not very even, it also create a lot of the cracking issue, because the thinner part of the liner always take the most of the force. Then the stress will focus on the thinner part. So when you during welding process, some thinner part is already crack. And also, of course, crack is not just that dimple, because if you didn't polish very well, create some the very sharp angle also create a crack issue. So to select very good thermoforming machine will be very important. So you can think about to better use the ceramic heating system, or use the very separate heating element to control the different heating temperature depends on the area of the material. Then you can make the thickness distribution is more even. And then let's talk about the moisture impact. Most of the material they will absorb the moisture. So we need to make a definition about water absorption. What is the definition of water absorption? So a polymer's ability to absorb in the retained water measures a percentage increase in mass. So you can see the diagrams that is what time this moisture will become saturated. It depends on the in the condition how humid the temperature, because when the temperature is higher, the humidity in the area is more higher, then you come with easier, faster, and make the material achieve the saturated condition. What's the problem with the material absorb the moisture? Because it depends on different material, they have different absorption of the moisture, and polyurethane is very sensitive to moisture absorption, because it's kind of the reaction with the water. When you do the thermoforming process, then it will create a carbon dioxide if you absorb too much moisture. So if you use a retainer, you can see most of the liner producer, they have asked you to use up those dental sheet within like 20 minutes, because after 20 minutes, the moisture will go inside to the liner sheet. Then you do the thermoforming, they will create a bubble. This bubble is not just because the moisture become air phase, it's also because of the degradation. So even you didn't see the bubble inside the dental liner, and they still have some problem that the mechanical properties will degrade. So it also create another crack issue. Also, I saw some of the laser cutting process. They cut the liner. There's another issue that because laser cuttings they accumulate very high energy, and if they have some moisture on the surface of the liner, then we also create another crack issue. So some customers, they need to do the nitrogen or dry air to avoid any moisture during the laser cutting process. So how to control laser cutting energy to avoid this kind of cracking issue is also very important. So if we use a copolyester, because the copolyester, you can see the figures. Copolyester has much slower moisture absorption range. So normally, multi-layer, they can open in the open condition for a few hours. They will not have no bubble. Of course, if it takes a longer time, then the moisture will penetrate through the copolyester surface into the polyurethane surface. Then when the polyurethane absorbs the moisture in the middle layer, then we have another issue that also will degrade and then create a bubble again. So I would suggest that normally, if the people or operator best ways that when they use the either single layer or multi-layer, they don't use it, they need to with some dryers inside or seal in a proper way to avoid moisture go inside again. So not just that, you can see they have a lot of problem. If the force going down, then the corrective power will lower. And so also when the water go inside, the dimension stability is changed. Then we have swelling issue. Then we also the fitness and the precision will be changed. So which means the orthodontic performance will be reduced. And also the property loss and the bubble formation is easy to see for customers' acceptance. Then I can show you this some pictures already show some aligners. So if the operator sees some bubbles on the liner, so can be a silver streak or some bubble inside, which means this diagram shows you can say like a polyurethane like 0.01%, properties something like say modulus, let's say 1780, and if they have content like the 0.08%, which means about 800 ppm, then you can see they already have about almost more than 10% property loss. If we have like 2000 ppm, then will become almost like a 30% mechanical property lost. So you need to be careful. Even you didn't see the bubble, if it have some impact on the performance as well. So you need to make sure there's no much moisture during the processing process. Okay, let's come to talk about the mechanical properties of clear aligners. Not like fixed braces. If you use a metal material, they have very more predictable behavior on the orthodontic force. But polymers are not like a metal material, because polymer is a thermoplastic material. They related to the we call force retention phenomena. So let's come back with the clear aligner therapy. Clear aligner therapy utilizes the elastic deformation of polymers to apply controlled force to teeth, induce a biological response in the periodontal ligament and the epidural bone, therefore achieving tooth movement. The force delivered to the teeth is caused by deformation recovery and the elastic properties of aligner polymers, which can be compressed, bended, elongated, distorted, and twisted, etc. However, most of the measurement of the mechanical properties normally is two-dimensional. It's very difficult to measure the three-dimensional, but if we move the teeth, it's three-dimensional. So how we can do? We just want to use the two-dimensional data comparison to think about he can also move the teeth on a three-dimensional way. Of course, most advanced brain company like Maxflex also have the three-dimensional simulation to measure the movement and the stress retention, how they perform during the wearing process. So anyway, let's compare with the very typical two-dimensional numbers we need to focus and understand. First one is the tensile strength and the stress curve. Tensile strength means you stress a product, then you have the tensile strength. Then the slope with the strength and the stress, the slope is called modulus. And the elongation means the elongation at break, how long they can elongate it and then never break. Then the polymer has a very special phenomenon called ear strain, which means when you over the ear strain, then they will then never come back. I think some mental also something like that. If you stretch too much on the spring, the spring never come back. So over this kind of a point, I mean this point for some percentage of elongation, then over this point, then we call this called ear strain point. Then over the point, you don't need to apply more force, then will deform and permanently. So we call this ear strain point. And the flexure modulus is different from the tensile. Tensile is like a stretch. Flexure is something like the bending. So because during you wear the liner, the force can be the tensile strength and also can be flexure stress, because some teeth you need to bend the teeth to one direction, and it will become a fracture strength. So fracture strength also it can measure by the slope of the stress and the strain curve. And the crack related properties is more difficult to explain because when you talk about a crack, it can be different dimensions. So in the material area, we measure based on what we call impact strength. Impact, we have some very sharp angle, or we call dark impact, which is no sharp angle, and to see how this kind of force can make it crack, or how kind of energy they can absorb. And the tear strength is called you tear something, then normally you will cut a very sharp edge, then you can tear it, then we call major tear. And also fracture toughness test, they have another kind of we call the charges type, or we call the striker angle type. And this also can measure the crack related properties. The hardness, if we actually hardness is based on the scale. So if we say if we go to very soft material, we can like show A, even lower than show A, they have show O or show double LO to measure the sponge. And the show A is very normal to measure the hardness of the elastomers. However, if the hardness is more than 90 show A, because it's a spring, it's very difficult to say 90 and 95 difference. Then they will move to another scale called show D. I would say that show A 70 will be something like a show D 20, then show A, let's say 80, maybe something like a show D, something like a 30, because the angle, the metal angle touch with the plastics is some of the very sharp like a show D, some of the more dark surface like a show A. So right now for a liner, they are measured based on show D, and Rockaway hardness is even higher one. So like the polyurethane, they use Rockaway hardness is more like a mental measurement to measure the Rockaway hardness. Like the Lubrons isoplast 2530, the Rockaway is something like 105. This kind of Rockaway hardness. But if the measure is show D, it's something like 87. It's the most highest hardness among those polymers. And the fracture resistance is that because you need to clinical installation and removal, so you need to make sure during this kind of loading and unloading process, and also during chilling and stretching, will make materials very easy to fractures. So how you can make sure this material is more durable and during the welding and the removal process, this will be another issue we need to measure and also need to look at that. Let's go into more details about mechanical properties. So you can see this kind of tensile curve based on different material. I make a list of 4 kinds of the common use in current market, will be something like a hard TPU and the copolyester, and also the heat resistance copolyester and the soft TPU. So you can see the curve very interesting. You can see like let's start from the soft TPU, which is the green line. You can see the green line. There's almost no air strain. So it's just it means it's a very elastic material. You stretch up, they come back, stretch up, they come back. So there will be not kind of a deformation and permanent deformation phenomena. So this will be very useful to deny us the part of the liner material. However, because it's very soft, which means they have very low orthodontic force, so they need to combine with a very stiff material such as hard TPU or copolyester. So in the market, there some people use the because of patent infringement issue, some liner producers or the dental sheet producer, they will use a 3-layer with a hard, soft, hard, or soft, hard, soft. Most of the material is made up of them is by polyurethane. So can be hard material outside or in the middle. They can have this kind of balance properties. And if you think about other material also being used, such as EVA or polyurethane, then there is also kind of elastic material. However, they are too soft, and they didn't have very good mechanical properties compared with polyurethane. So it's not the top priorities choice for this kind of material. You can see the slope of this material. So this slope also shows that it requires to stretch this material require different force. So you can see retainer. They use the hard TPU, so it's the modulus or its slope is very high, which means they think they can maintain the teeth on its right position for a longer time. Of course, because it's also very durable, because polyurethane is almost one of the most durable material in the market. This can see this curve. In the first movement, we call elastical region, which means the material being stretched, then if not over than the yield strength point, as I mentioned earlier, it will come back to its original shape. We call this final the host loss very low. And initial slope is also we call this elastical modulus. And in a microscopic way is that polymer is being stretched, but they come back to original conformation when unloaded. So when you unloaded the aligner, they come back to its original shape. However, the real world is not like this way, because it can be unloaded for a long time. So because of high temperature, because of the force difference in different areas, so normally it will decay for a certain degree. And most of our performance product can still maintain about 75 to 80% force during wearing period, normally 7 to 10 days. Right now, most of people understand if you use the good performance aligner, 7 days you can move the teeth with the predictable position already. So it's been changed for the last 5 years. 5 years ago, then people say, oh, we need to wear aligner for 14 days. But right now, 7 to 10 days is enough to move the teeth. There's a lot of clinical data shows that it's perform very well within 7 to 10 days. So if you you stretch the aligner too much, then you over the ear point, then will not come back anymore. But if you have with elastomers, whether outside or in the middle, you have a very good resistor to the deformation. So it's very easy. You can check it by yourself. When you have a aligner or have make some aligner product, you just switch into like 180 degree, then come back to see how fast they come back to the original shape, and to see how they deform or not. So if you have a good material, then you can see they have almost no change or no deformation of the aligners. And the negative means that they really material become thinner, and the deformation and the stress dropped, which means this material already been stretched too much, and they will come back. And the fracture point means if you really stretch the material too much, then there will be break. So toughness is that when you say the energy absorption, I would say that multi-layer, if they combine with a very good more tough polyurethane in the middle, they can absorb more energy, which means the crack resistance is much better than other material. Okay, let's come talk about more detail about elastical modulus. This is very important because when you talk about elastic modulus means when you move the teeth, like you deny like a 0.2 millimeter movement during the wearing process. But what you don't know is that elastic modulus is not always the constant during deflection, even less than the yield strength. So there's three factors. I would say if we in the future, if our material can combine with some treatment plan software, then we can understand during the oral environment such as the loading force, such as the temperature, such as moisture condition. Based on these three factors, then we can precisely to measure elastic modulus. Then we can provide more predictable force during the teeth movement process. So let's think about, I show the three diagrams here. First one, you can see, as I said, you drink the hot water. Hot water means the material is under the higher temperature condition. So it means that you can see the first diagram, the strain and the stress at different temperature is a bit difference. So if we go to the higher temperatures, then we'll be making the material deform very easily, which means provide this kind of orthodontic force with much more slow or much more weak. And so this is one point. Second point is that some material, there's some higher water, and more higher water absorption also will reduce the elastic modulus. And the third point is that during the wearing process, during the different loading weight, so when you deny different force movement or different twist of your teeth, you need to provide different torque. You need to think about the elastic modulus under your deny, under your movement distance, and then you also need to think about the force under this kind of the material stress will be cause another problem is that the force will decay. We call this in our polymer science, we call this creep. This creep means under high pressure and longer time, this kind of material will have a permanent deformation. So you need to consider these three factors. So if you choose like a higher TG and a more rigid material, then this kind of elastical modulus will be more consistent or more less effect by the environment, such as water, such as loading, such as high temperature. That's the reason when we deny the material, we want to deny higher TG material. But higher TG is much more difficult to process compared with the elastic material. So I would say if you use more higher TG material, you can provide more predictable elastic modulus. If you combine with the different polymers, then you can see the elastic modulus is quite different. So if you see the polyurethane, you can say is the elastic modulus about 2,200. Then the PTG is a bit lower, about 2,100, and PCTG even a little bit lower, is about 1,500. Then multi-layer, because they have about say 400 to 500 modulus and in the middle. So in average, they have a double modulus 1,000 to 1,200, depends on the denied formulation. So how to balance the modulus with a more effective movement of the teeth and provide comfort with lower modulus is very important. And also the lower modulus have the minimal effect on attachment, because it's higher modulus means when you take out and wear out on your teeth, they will have a more difficult to wear it. Then there will be problems that it will have more force on attachment. Also during the treatment process for few weeks later, because attachment normally is on the patient for a longer time, not like a liner. So each movement, if there's a big risk of attachment be abrasive, and also maybe will be drop off on your teeth, they need to do another treatment to adhere the new attachment. So it doesn't mean then you need to have higher modulus on your aligner to move your teeth. It means, as I said earlier, into continuous and more elastic modulus. How we measure elastic properties? I would say if you twist the aligner, then if it come back faster, means it rebound faster, which means they move your teeth faster. So it's very easy for most of our users. They can twist the aligner to see how fast they come back. I show you two products. This is the retainer material. This is based on the polyurethane, 100% polyurethane single layer for retainer. This is the multi-layer based on the PTP structures, polyethylene, copolyester on the outside and the softer TPU in the middle. So let me show you a little bit difference. You can see this is very rigid. So normally the problem is that the patient or the operator think this, even dentists think this is harder. But actually the thickness is exactly the same. But you can feel this is thicker because its modulus is higher. So you can see it's very not very elastic. And this is very elastic, which means you can see there's something come back and forth. So if you move the teeth, actually more elastic means you can move the teeth faster. So you can have a very easy judgment of how elastic the material is to give you more rebound and give you more force to move the teeth. And more and more clinical cases have been proved that based on multi-layer, they will move the teeth faster than a single layer. Retention, you can see these figures. They can, if the elastic material, hopefully they can provide a constant constraint, so the stress will be the same. But it's almost impossible for all the material. But if they can, hopefully they can, the stress can maintain as less as possible the loss, then that is good enough. So right now, if you select a good material such as higher TG and also more branch polyols, and also have a more close linking areas, then this kind of polymer type, and will give you have high stress retention. And also some material have a big influence by environment, like the TPA is a nylon material. They absorb the water more quickly than have the problem with when you apply the force, the dimension will change, and also the force will lose a lot because they apply the water. Water is kind of changing their structure of the molecular. So there will be another issue. So I would say we have provide all kinds of comparison, and I think most of the academic research institute, they also study this a lot. They make sure during the treatment period they can provide a very constant, continuous stress. So we also use our denied machine can check this one, and they can see here. So we can use once use China, they have this kind of regulation based on 24 hours and 0.5% strain, and under 70 degrees seawater, they can see how they change. So Maxflex, the multi-layer compared with a single layer, have the best stress retention, more than 70% stress retention. But if others, you can see they lost a lot, and so it gives you another idea. So it's not means you need to have very high initial force make you move the teeth faster. Actually, you need to have a very more moderate force and continuous and no loss force if possible. and to provide you the best stress retain ratio is the key to have the best performance of the clear aligner treatment. Of course, you can see another thing is that if you have use the material under different conditions, such as very high humidity and also very high temperature, actually all the properties drop a lot. So you can see, compare with the single layer like copolyester or PPU, after a few hours, like 2 hours in 50 degrees C, you can see the performance, they drop more than 50%. So this is a very key. People, some brand owner advises the patient don't drink hot water or hot coffee during wearing aligners. But ours, Maxflex, they can no problem. And then you can also do your test by yourself. Like you can use the band and with a different aligner put into like 50 or 60 degrees C hot water and see which aligner deform most. Then if you deform most, means its stress retention is poor. And this is the ear strain. Ear strain means when you during the wearing and take off the process, you will strain the aligner longer. So if you use in the past, you can see a lot of people still use the copolyester as the aligner and also as a retainer. So because they have a very low ear strain, so it's easy to crack. So this reason single layer of copolyester is much more less and being used right now. And then this kind of tear strains, they measure how this kind of scientific measurement method to measure the crack resistance. So we see the area they cover, means the polyurethane have some more energy using the larger tear strains. So you can see the tear propagation and the energy under the curve is the bigger. So multi-layer can absorb much more energy than single layer, which means its crack resistance is much better. So I give you some example about the crack resistance. According to our customers' statistics, we are about 1 or 2 cases per 10,000 cases have this kind of crack issue. But if you go for like a copolyester, then normally it's about 2 to 3% of the crack issue. So this reason multi-layer become more and more popular. This comes to talk about other key properties. So we'll talk about the transparency, talk about heat resistance and the stain resistance. So transparency, right now we spend a lot of time to provide the best protective film regarding the sticky and another dental sheet, because need to be make sure during the forming process you will not be delaminated, and also make sure it's easy to take out during after the process. You need to take out the protective film without sticky and aligners. So how to make a good protective film is very important. The thickness of a protective film also very important. Right now, we are choosing something like a 0.065 millimeter thickness, and after forming, they were down to like a 0.03 to 0.04 millimeter thickness. So based on this, they have many good advantage, make the aligner more clear, and also they have avoid any kind of VOC or contamination come from the 3D direct printing models. So, and also because of the printing process, some operators want to speed up the printing process, which means they can increase from 15 millimeters per minute, they can increase up to double, like 100 micrometers per minute to increase the printing speed. But if this speed has been double, then lamination has been more clear, which makes the aligner become more opaque. So with protective film, right now, Maxflex, the customers have more than 80% they require protective film, and they also have no problem during the automatic production machine process. And during this kind of process, the protective film during the melting process will not delaminate or falling down on the heating element. So this is also very important to choose the good protective film, making sure during the automation process they can produce very good high clear aligners. And of course, the material itself is very important. So the material comes from different suppliers, different transparency. So some of the material they use the like the bio-based polyols. They have a natural, a little bit yellow in color. But if you use the petrochemical-based polyols, then they have more high transparency. So on this table, you can see this normally their transparency is something from 85 to 90%. This is good enough to be a liner. Then let's come back to talking about the heat resistance of different polymers. So if you use the higher TG, as I said earlier, it means to have a higher stress retention. And also higher TG material, you can drink hot water, hot coffee without no deformation of the liners. So we do a lot of experiments such as put the material under like 68 degrees C for 30 minutes. Some of the material is already deformed. But if you have high TG, it means the better heat resistance, they have not deformed. So this is very important. So most of you can do this test by yourself. And you just use a different liner and bending and put on the hot water to see they have a good heat resistance or not. But as I say, good heat resistance means high stress retention. So it's easy to understand which company provide you the good aligners. A stain resistance is another issue. You can see that. So for softer, hard, soft, as I said earlier, the soft material can absorb a lot of stain easily because it's soft material. And individual liner, they claim the smart track actually is the 1A1 structure with a soft on the outside. So based on this outside material, is frankly speaking, it's easy to have a stain on the soft material part. So compare with the hard, soft, hard material, soft material have a poor stain resistance. So in general, you can see I summarize the above mentioned properties. So these are all the requirements for a good aligner. What kind of property they need. Start from tensile modulus, dimensional stability, comfort, low water absorption, light transmission, and low elongation yield, and good crack resistance, heat resistance, UV resistance, and stress retention, higher stress retention, and good stress resistance, and with the moderate hardness and the failure resistance, and a very good processability. So in general, you can see the right side is the best way for the combination is a multi-layer. Okay, I give you a bonus. This is called biomechanical property compared with a sheet structure. This one you can say if you have a soft material on the surface, which means the force will be more gentle, then the force is not really as predictable, controllable on a certain area. So like here, moderate area means will be more to the root area, to the contact area. More soft area, the force will become more cover, more area, more gentle, so also more less. So depends on the performance or requirement of different patient and dentist or orthodontist. They may choose some in different treatment. Some patient they really feel very not comfortable at the first stage. So right now already some orthodontics or some aligner producers, they with the mixed treatment like to reduce the force at the beginning stage, then increase the force at the second stage. They can call 7+7 or 7+3. This is kind of a mechanism to first one, make the patient will not face a very high force, make them pain, so they can reduce the pain. Then later on, when the teeth start to move, they shorten the treatment time with a higher force or thicker liner. Some people will move from the 0.76 move to 0.89. So this is another things we can do to do combination of treatment. I hope in the future the people can have their own choice based on different patient, different the movement. They can choose different liner. This is our aim, and I really feel any of our partner or potential customers want to give us more feedback about how we should do in the future. I welcome your feedback.